In this video, I'll be talking about the associative and commutative property of matrices. So, as far as associative property is concerned, let's say we are given A, B, and C, and we are asked to find the associative property of A, B, and C. It's going to be in the form of A plus B plus C equals to A plus B plus C. So one thing that you guys should note is that the positive here, the plus I'm using here, it's actually a notation. That is, it's a sign that shows the relationship between A, B, and C. But the differences between this and this is that looking at B and C here, both are enclosed in a bracket. Looking at A and B here, both are actually enclosed in a bracket. So the associative property states that A plus into bracket B plus C must be equals to A plus B plus C. But it depends on the sign, or let me just say notations that we have. If A plus into bracket B plus C is equals to D, then what if we have negative sign, which is minus? Can A minus into bracket B minus C be equals to A minus B into bracket minus C? Well, we see that in the question below. Then, what of commutative? Commutative is just, let me just say, commutative deals with just two elements. But let me say we have elements A and B. Then A plus B equals to what? B plus A. This is the commutative property. But let's say we have negative now. Let's say we have A minus B equals to B minus C. Can this be equal? Well, we see in the question. So what I'm saying is just that, is it that associative and commutative is only applicable for positive and multiplication sign? Is it that it's only applicable for positive but not for negative? Is it applicable to negative, positive but not to negative? We see in this question. So let's just move to the question. If you can actually solve it, just go ahead and solve it. Then let's move to the question now. So in this case, I'm given A to be this, B to be this, and C. But here I will be calling them matrices. Matrix A with its element, matrix B with its element, and matrix C with its element. Now let's go. The first case here, I'm asked to find A plus B. Show that A plus B equals to B plus A. I'm not asked to find, I'm asked to prove in this case. Then A plus B, that's the first thing I need to do. Then A plus B, then where is my matrix A? Matrix A, 1, 3, 8, and minus 6, right? Then plus matrix B, which is what? 4, 0, 3, and 1. I'm asked to show that this is equal to B plus A, which is 4, 0, 3, and 1, right? Then plus 1, 8, 3, and minus 6. This is what I'm actually asked to show. So let's see if this is actually going to be equal. So now 1 plus 4 giving 5, right? 8 plus 0 is the 8, this is 6, and minus 6 plus 1, that's actually minus 5. Then is it equal to 4 plus 1 giving 5, 0 plus 8 is 8, right? 3 plus 3, that's 6, 1 plus minus 6, that's minus 5. Is this equal? Yeah, well, to verify if it's equal, we need to check the elements in here and the elements in our that are present in the matrix of this side and also this side. If both are actually equal, that means the law holds true for A plus B and also B minus B plus A. Exactly. So we have 5 here, 5 here, 8 here, 8 here, 6 here, 6 here, and minus 5 here. So since both actually contain the same elements, that means this and this are equal, which means it is what? Proved. Then let's simply move to the second question, which is show that A minus B equals to, actually it should be equals to, I want us to verify first. I know it is not, but let's verify it first. Why I put not there? Equals to B minus A, exactly. Likewise, the same thing here. Let's verify first if it's going to be equal or not. So now our matrix A is 1, 8, 3, and minus 6, right? So minus matrix B, which is 4, 0, 3, and 1, equal, we have B, which is 4, 0, 3, 1, right? Then minus A, which is 1, 8, 3, and minus 6. Don't mind me, actually, no, space, I don't want to waste space. So let's go. Yeah. 1 minus 4 give me 1 minus 3, right? This minus 0 is nothing, that's 8. 3 minus 3, that's actually 0. Minus 6 minus 1, that will give you minus 7. Right? So this is the first case. Then is it equal to 4 minus 1, which is 3? Or the best. 0 minus 8, which is 0. Look, listen up. 0 minus 8, which is what? Minus 8. Minus 8 here. 3 minus 3, actually 0. 1 minus 6. 1 minus into bracket minus 6. That's 1 plus what? 6, which is what? 7. So here I'm having 7. Now, are they equal? Well, we can say if we try to ignore the sign or the arithmetic sign that is in front of each element, both both matrices are actually the same. But if you want to consider the sign that's in front of each element, both matrices are not the same. So this is not equal to this. Since we have minus 3 here and 3 here, we have 8 here, minus 8. We have 0 here, 0 here, minus 7 here, and 7 here. So both elements are not the same. So we cannot say, okay, this can never be equal to this. The commutative property doesn't hold true for this, but it holds true for what? For this. Now, let's move to the third aspect. The third aspect I'm having here, I'm asked to show that A plus B, A plus the bracket B plus C equals to what? A plus B plus C. So the case of this, I'll be solving it in a separate white paper here because I don't have C's. So now my A is this, right? I'm asked to show that A plus B plus C is equal to A plus B plus C. So let's go ahead. What's our matrix A, right? My matrix A is simply 1, 8, 3, and minus 6, right? Then plus, let me open those big brackets here in this case, right? So I'm having B and C, which is 4, 0, 3, and 1, right? Then close the brackets. Then plus another one, which is 5, 3, minus 1, and 4, which is my C, right? Then I'm asked to show if it is equal to B brackets here, which is my A, which is 1, 3, 8, and minus 6, right? Then here I'm having plus what? Plus what my B, that's 4, 0, 3, and 1 in brackets, right? Then I'm having plus just my simple C, 5, 3, minus 1, and 4. Sorry for my distance is somewhat small. So let's go ahead and solve this. Well, as far as mathematics is concerned, following the rules of mathematics, I actually need to consider the bracket first, right? That means I will solve everything in here. So I'm having this back as 1, 8, 3, and minus 6, right? So then this is going to be what? Let me just put plus here. I'm having 4 plus 5, that's 9. 0 plus 3, that's actually 3. 3 plus minus 1, that will give me minus 2. 1 plus 4 is actually 5. Is this equal to something here, which is 1 plus 4, 5, 8 plus 0, we have 8, 3 plus 3, that's 6, minus 6 plus 1, that's 5. Right? Then plus again, I'm having this to be 5, 3, minus 1, and 4. So now let's go ahead and simplify further. 1 plus 9, that's actually, I'm having 10. 8 plus 3, that's 11. 3 plus minus 2, that's a minus, that's 1 exactly. That's 1, minus 1. Then minus 6 plus 5, that's giving me 1 again. Right? Well, in this case, it's actually minus 1. Is it equal to, that's 5 plus 5, which is 10, 8 plus 3, which is 11, right? 6 plus minus 1, that's 5, right? 6 plus minus 1, that's 5. Then 5 plus 4, that's actually 9. But wow. There's a mistake somewhere. Let's try and check. 4 plus 5 is 9, that's 3. 3 plus minus 1, that's minus 2, right? 1 plus 4 is 5. And 1 plus 9, that's actually 10. 8 plus 3, that's 11. 3 plus minus 2, 3 plus minus 2, right? No. This is where the mistake comes from. Exactly. 3 minus 1 is actually 2. So here we are having 5, not minus 1. Sorry. So here is 5. Then let's verify the next one. Minus 6 here, actually, then here I'm having 5. Minus 6 is I'm having minus 1. Alright. Then in this case also, 1 plus 4 is 5. 8 plus this is 8. 3 plus 3, that's 6. Then minus 6 minus 1 is minus 5. This is where the mistake comes from. Exactly. So that's just it. For the best. So let's just simplify this further. 5 is given 10. This is 11. This is what? That should be 6 minus 1 is 5. Then minus 5 and plus 4. That's actually minus 1. Exactly. So this is minus 1. So the elements are the same. So it shows that this is equal to what? Equals to this. That means associative property also holds true for this in terms of addition, right? You know, this actually includes 3 different matrices. But here we have also what? That's a true matrix. So both commutative and also what? Associative property actually holds true for the addition of what? Matrices. So now let's just move to the next question. The next question here, I'm having question 4, which says, I show that A minus into brackets B minus C is equal to A minus B into brackets minus C. Is it going to be equal? Well, we see in just a moment. Now let's go ahead and solve this. My A is actually, that's a 1, 8, 3, and minus 6, right? Then I'm having it here, and minus, let me open big bracket here. I'm having B, which is 4, 0, 3, and 1, right? Minus C, my C, which is that's actually 5, 3, minus 1, and 4. Then equal to what? That's a 1, 8, 3, and minus 6, right? Then here I'm having that's a minus again inside. I'm having 4, 0, 3, 1, and I'm having minus what? That's 5, 3, minus 1, and 4. Exactly. So now let's check if this is going to be equal. Now the first case, now I need to deal with the brackets first. I'm having 1, 3, 8, and minus 6, right? So minus, simplifying this, that will be 4 minus 5 giving me minus 1, right? 0 minus 3 giving me, that's actually minus 3, right? 3 minus 1, that's 4, right? 1 minus 4, that's actually minus 3, right? So this, well, that's for this. So now let's move to the next one. I'm having 1 minus 4, that's minus 3. 8 minus 0, that's actually 8. 8 minus 0, that's 8. So 3 minus 3, that's 0. Minus 6 minus 1, that's what? Minus 7. Right? Then here I'm having minus into bracket, that's 5 minus 1, 3, and 4. Is that? So in this case now, let's go ahead. Then here actually I'm going to do this here. 1 minus minus 1, that's actually 1 minus 1 minus 1, that will give me, that's 2. Exactly. I'm having 2 here. 8 minus minus 3, that will give me what? Plus 11. 8 minus the brackets, 8 minus the bracket minus 3, that's actually 8 plus 3, right? Which is 11. 3 minus minus, that's 3 minus minus 4. 3 minus 4 actually. 3 minus 4 is actually minus 1. Then minus 6. Minus 6 again. Then the bracket minus 3. That will give me minus 6 plus 3, which is what? Minus 3 exactly. So here I'm having minus 3 here, right? So which is equal to this, which is minus 3 minus 5, that's actually minus 8, right? 8 minus 3, which is 8 minus 3, that's 5, right? Then 0 minus minus 1, 0 minus minus 1, that should give me plus 1, right? I'm having 1 here. Then here I'm having minus 7 minus 4, that's giving me, that's actually minus 11, exactly. So if you look at this, are they equal? No, 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 they are not equal. It shows that associative property and commutative property doesn't hold true for both, for the, let me just say, for the subtraction of matrices. It doesn't hold true.